Welcome back to my channel, guys. This is another example from solutions to problems involving surface areas and volume of solid shapes. So here we have in the diagram below, OABCD is a pyramid with a square base of side 2 centimeters and a slant height of 4 centimeters. We want to calculate correct to 3 significant figures. Question A, the vertical height of the pyramid. And also we look at the volume of the pyramid. So very quickly, let's quickly take my solution on this side of the page and see how this goes. Now, since we want to find the vertical height of the pyramid, I want you guys to focus on the representation of everything related to this pyramid. For example, if you look at the base of that pyramid, okay, you will realize that the base of that pyramid is a square. So if I start from the square base, which is the square ABCD, comma, and I quickly just draw a simple square, okay, to follow through with what I want to talk about. And I label also as the square ABCD, just like we have it in the diagram. This is 2 centimeters and this is 2 centimeters. Of course, we have a line, okay, which is the diagonal of the square. We have the center of the square right here, which is called N, okay. We know that every corner of a square is a right angle. So which means that I can easily focus on the right angle DBC. So from the right angle triangle DBC, we all can agree with me that DB squared is going to be equal to BC squared plus DC squared from the Pythagoras theorem. Okay, so that means that DB, that means that DB is going to be equal to, just a minute, DB is going to be equal to BC squared, which is 2 squared plus 2 squared, and of course DC over here squared, and DC squared is 2 squared as well. That's a square. This will give me 8, that is 4 plus 4, so that DB can therefore be equal to the square root of 8. The square root of 8 in short form can be seen as 2 root 2 if you simplify solidically. That is 2 root 2. But in decimal, you're going to have the answer to be 1 point. Okay, that's going to be the square root of 8. 1 point, okay, I think that is going to be multiplied by 2. Should have given me 1.414 for root 2. And then multiplying that by 2, I'm going to get 2.828 centimeters. Now, from that square, you will realize that DB is the diagonal. Now, DN and NB will be equal to each other. Let's take a look at that. DB divided by 2, that means from D to N and N to B are the same, because that point in the middle there is the center, is the midpoint of your DB. So that simply means that DN is equal to NB, and they are both equal to 2.828 divided by 2, half of that. Okay, divided by 2. So the final answer for NB is going to be 1.414 centimeters. Now, what we have calculated here is NB. So our focus is on NB now. Now I would like to focus on another triangle. So from triangle ONB, which is coming from my pyramid, I want to bring out that triangle I'm talking about from the shape. I'm talking about this, this, and this. Okay. That triangle right there inside that pyramid is the triangle I'm talking about, triangle ONB. And that triangle, basically, if you look at it very well, is a right-angled triangle. And for a right-angled triangle, where you have, okay, quickly, I want to draw the triangle so that we can follow. Where we have, this is N, this is B, and this is O. Let us represent ON as the height. In fact, ON is actually the vertical height of the pyramid. The slant height OB right here is 4 centimeters. Remember, we initially calculated over here NB to be 1.414. So we can drop that here, 1.414 centimeters for NB. Easily, we can quickly calculate the value of ON because we know that ON squared by Pythagoras theorem again is OB squared, definitely minus OB squared minus NB squared. I believe that is clear using your Pythagoras theorem. So this is 4 squared. Okay, this is 4 squared minus 1.414 squared. So calculating this, we should have it to be equal to, okay, 16 minus 1.414 squared should give you 2. So that means I have that to be equal to 14. Now, I'm sure you can observe that ON from that triangle is actually the height of our triangle, which is also the height of the pyramid. So height, which is the vertical height, is the square root of 14, which should give us our answer as the square root of 14 should give us the answer to be 3.742. 3.742 centimeters. Okay, so we found our height. That's for question A of the question, and that is solved already. Question B is to find the volume, okay, of the pyramid. The volume of pyramid, as we know before, is actually equal to, volume of pyramid is equal to 1/3 times base area, okay, times base area, very quickly. Okay, 1 minute, all right. Times base area, let me put that down, finish it up. Then times the vertical height. So substituting, this is 1/3. The base of our pyramid is a square, so the area of square is L squared, so times height. And what is the length of the square? The length of the square is definitely 2. So that is 2 squared and multiplied by the height already calculated as 3.742 centimeters. So when we calculate all that together, we are going to get, when we do all that calculation, we should get that to be equal to, the final answer for that calculation should give us 4.988. Should give us 4.988 centimeter cubed as the volume. We can approximate this to well, the question said to 3 significant figures. So that is 4.99 centimeter cubed as the final answer to 3 significant figures, 3SF. And that is how this is solved. That's the correct answer. I believe you understand this very quickly. That's easy. Thank you very much. I'm going to see you in the next video with the next example. All right, guys. Bye for now.